My contribution to this panel and to the special issue will be trying to give an additional viewpoint in which we consider the fact that self-awareness models should be created by signals that an agent perceives. So we will speak about multi-sensor signal-driven self-awareness. You can find in our special issue paper more information about what I will say. But in this way, we try here to concentrate more on what features, as related to the question that were given at the beginning of the panel, we try to concentrate on what the features this self-awareness model should behave from the point of view of being directly created from signals. So here the concept of emergent self-awareness aims to be a synonymous of signal-driven. So if we want that an agent produce this model continuously and use this model inside itself, what features this model should have, and how these features, these models should be available and what advantages can give to an agent that use it. This is a figure from the paper in which we can see, for example, an example of an agent that has proprioceptive and exteroceptive signals, and that can create models of self-awareness from dynamic observation of the signal. We can imitate, in some sense, what happens in natural agents, and we have a literature that is considered in the paper that starts from the point of view of looking how, for example, the neuron fire in humans, and how we can process the signals that are generated by observing this neuron firing in such a way to monitor what kind of correlation are present between such neurons, and to allow how this neuron firing can basically resonate with what the agent is doing, giving to him a sort of reflection of what is happening. Also in signal processing, we have nowadays a lot of literature that can provide to us methods that can allow to start to understand how to create multi-level signal representation and processing that basically can help an artificial agent to do this. And so this figure on the right is something that can be considered in the paper as a starting point to create a kind of model for, kind of processing model for arriving to this emergent self-awareness for artificial agents. And in particular, if we can look a little bit to what we want to build such features, is that this self-awareness model should allow an agent to predict what will happen in the future based on past experiences. And so the model that we learn should capture these principles at each time instant. We told that such a model that are composed by different variables that can be learned from data can allow us to understand if the current situation is normal and abnormal. So in this paper, we will use the term of generative self-awareness model to describe what can be a model where we can infer some guess about some variables when we know some other variables. So the model is complex, but we can split it in different subparts. The problem is that when we observe abnormalities, we would like to be able to learn new models. So from experiences in when we have deviations from what we have captured in previous cases, we can want to be able to incrementally update the agent self-awareness. And also, we would like that the models that we are able to learn can, as already said, be useful, for example, for exploration and exploitation, that the agent can carry on by its own decision-making and control processes. So here is an example of what I was saying, in which we have an example of two agents cooperating to do a task, and the two agents are two cars that moves inside an environment. And we can see that one of the agents can, for example, the follower, look simultaneously at multimodal data, for example, look at images and look at the positioning sensor that can give simultaneously the representation of what is happening in heterogeneous ways. The problem is that we would like to create models. One of the bottom left here is an example of a model composed by different variables that can be learned by observing a given initial experience. But now the problem is that we want to live in real life, and if we want to have emergent self-awareness, when something different occurs, so for example, when one of the vehicles on which we are concentrating the self-awareness part, basically meets some abnormalities, here is a pedestrian that is met doing the same job, we would like to be able to capture abnormalities from this model. So it's the model itself that by looking at predictions that are mismatched with respect to current observation can detect abnormalities. And the cycle tells us that we would like then to incrementally memorize and store new models of this type from this cycle. So the paper deals with this and explains how to do this. It is necessary that the model is capable to capture between variables temporal correlations. It's necessary that one learns and incrementally learn from abnormalities different conditional properties between what happens at the continuous signal level and what happens at the discrete level. And also the problem is that we would like that models related to the different modalities are appropriately correlated to explore what is sort of causality, intermodal causality between these levels. And clearly, to do these things, you need models that are necessarily dealing with uncertainty. The model presented in the paper is based on probabilistic theory, for example, and this allows to explain the uncertainty contained in the sensors and the uncertainty contained in the models. We speak about generative properties and discriminative properties, and you can find more details on this in the paper, because the models that you need to create this emergent self-awareness should be capable to provide all the features I told before: prediction, capability to learn from abnormalities, and to discriminate between different types of abnormalities that can happen. So as a concluding remark of my point in this panel is that we are probably nowadays in the condition using, for example, methods that come from signal processing like probabilistic graphical models, or methods like more recent like supervised clustering, deep learning, and statistical mechanics. One can be able to learn these models, and in the paper you can find ways by which this can be done. Also, this means that in the future, as a future part of what we need to do in the future as a research community, is that what is proposed in the paper is already a consolidated solution, but clearly this opens a field of research that integrating what I concentrated in this lab, in this part, and what we have seen from the other papers in this issue of the proceedings can be done. Thanks, Bernard.